Hello students, let's start today. Mm, Today we'll do random variable. Random variables we are having two types. We have two types of random variables. First of all, a random variable is a variable whose value depend on outcome of the random phenomena. So we have two types of random variables. First is you can say numerical random variable, which is number based, and then we have categorical. See, within the numerical random variable we have two types. You can say yes, let me put it this way. So first is the discrete. Within the numerical random variable we have two types here. You can see first is discrete random variables. This is first type, and second type is continuous. This one. You can see over here, discrete random variable means within the numerical we have this discrete random variable takes on integer value and non-floating point. So any number, okay, like 1 2 3, all these are discrete random variables. And continuous means which is having floating number. Like a continuous random variable can take on any values with a given range including floating point, 10.2, 10.10. So these are continuous random variable. Okay, it is numbers, numerical but continuous. Okay, how many parts do we have in the categorical now? Definition. A categorical random variable takes on values that are names or labels representing different categories or groups like red, blue, green types of animal, cat, dog, bird. These are the categorical. You can say the string also is one of the same thing. All right, so this is the thing. Then we have covariance. What is the meaning of covariance? Anybody, you can write in the chat. Okay. Not audible, sir. Huh? I think about to find a relationship between two variables is called variate. To find a relationship between two variables is called covariance. Yes, that is correct. How much value of one variable varies with respect to other variable? How much value of one variable varies? Yeah, that is fine. Okay, let's read the definition here. Wait, let me see why it is showing like this. So we have a formula. So what is covariance? We can say covariance covariance is the measure relationship between two variance. It's a parameter of relationship between the two variables, indicating how changes in one variable are associated with changes in another. In the context of data analysis, these two variables are typically represented as columns in a data set. Okay, see, there is a formula to find a covariance. Okay, let me show you this formula. This is the formula. Hmm, I think you people cannot see it. Just 1 minute. Yeah, this is the formula. Population covariance formula. If you are having a bigger population, then it will be x1 minus x mean, y1 minus y mean divided by n. Okay. If you're having small data like sample, if you're working on sample, you will be having like x1 minus x mean, y1 minus y mean divided by n minus 1. Okay, so you can see there is we can easily see here, yeah, that in the covariance, right, in the population we are dividing with the n, and in the sample we are dividing with the n minus 1. What is the reason behind it? Do you know? Write in the chat. I will come to this topic again. Let me tell you why we are getting the n minus 1 there. The reason is this. We can see, first of all, does anybody know why we do this? Why we divide the population with the n but sample with the n minus 1? No, nobody knows. Okay. You know what happens? Okay, let us read this first, then I will. Uh, co Covariance correlation n versus n minus 1. Population, in the population, you have the data of the entire population. The formula uses n denominator. So no need for the bias correlation as you are using the actual data. So suppose we are doing lot of data, like a number from 1 to 100. Okay, this is population data, and you are finding the correlation, so you will divide it with the n, right? So see, because it is population data, you will exactly get the covariance of this, right? For example, suppose you will get 10.1. But here, when you have the sample subset, the formula uses n minus 1 in the denominator. So n minus 1. Using n minus 1, Bessel correction provides an unbiased. So this is the meaning is that suppose in the n you already know that you have a very small set of number, right? So from the small set of number, how can you think that we will get the uh, exact covariance same like this? We will be not getting something like this. We might get something like a 9.1 or 9.2, something like this, right? If you divide it with the if you divide it with the n, right? Then only, okay, sorry, wait, I have to find a variance. If you divide it with the n, if you find a covariance, just 1 minute. Yeah. So if you divide, you will get the covariance. if you divide it with n, you will get a covariance 9.9, which is not equal to this, right? So what you will do, you will divide, you will decrease one number here, then only you will get 10.1, something like that, right? Near about the real mean. So there is a lot of research gone here to find out like how many numbers should we decrease so that we get the exact similar to the population of the real numbers. So they found out that it should be -1. If you do -1 in the sample data, you will get something related to real covariance, right? So this is the reason. Let me explain you in a good way. Like, see, if you take the data of mm, suppose you take the data of like the height of the people, okay? This is of only 20 people, right? You will find out that the mean is 5 foot 3. And if you try some more data, you might end up getting something like this. If you try 20 more, maybe in Australia, if you try, if you will get what we can say, maybe 6 feet, right? 6 feet. But is this the real mean or covariance? You can say. Let's understand in the terms of mean. Is the real mean system bucket? You tell me. No, it is not the real mean. You'll get the real mean whenever you collect a lot of data, right? You'll collect maybe hundred or thousands of data. Then only you will get a roughly good mean, which is 5.9, right? So you have to collect a lot of data to get the real mean of the data. So this is what happens. We are matching our this mean with this one. So what I will do, here you're getting a lot of dividing with 100. So you might be getting 5.9 as a, you can say, the average, right? But what if you are getting very small, dividing it very small number? Will you get a number exactly something like this, which you see here? No. You will get something which is around this real mean, but not exactly that, right? You might get 5 foot. So that's why to match this one, the real one, you have to decrease this number. Okay, we will decrease this number, then only you will get the something about 5.9 or 5.8. Okay, so to match the real one, that's why we do this. Let me see, do I have any kind of animation which help you to get this? Wait. Hmm, Wait. Yes, I think I got some picture. See this. They are explaining with the help of picture. Observe this and tell me what is happening here. I want answers from each of you. What is happening here? As the sample increases, we are converging to the mean. हाँ, right. छोटा सा सैंपल लेके we cannot say कि वही मीन है उसका, right? एवरेज मीन ऑफ द सैंपल. जैसे फॉर एग्जांपल वी आर लिविंग ऑन अर्थ, तो आप अपना घर देख के ये नहीं बोल सकते कि धरती फ्लैट है, राइट? क्योंकि आपने बहुत छोटा एरिया देखा है. If you go a little bit up to your building or maybe 10 story 20-story building, you will see a little bit curvature in the land. If you are traveling in the plane, you will see a proper curve, right? Because you can see the now bigger perspective. So this is how happens with the population and sample. Sample is a small perspective, population big. So population is like a data of, this is what I was trying to make point here. Okay, let's go back to the here. That's why we do n and n minus 1 here. Okay, to like level them up. Covariance formula. Okay, covariance. All right, one more thing I need to tell you here. Yeah. Suppose basically this covariance will give you values. Okay, if two columns are highly correlated, it will give you values, not small or bigger values, but of values, positive and negative values. Fine. So for example, let me show you what I mean. Hmm. See this. correlation coefficient. These are the some graphs you can see. So if it is showing one value, then it means it is highly correlated. Plus 0.9 plus 0.9 means it is correlated but little bit less than the 1. 0.5 is fine but 50% correlation. Low positive correlation, high positive correlation, perfect positive correlation. Minus 0.5 means low negative correlation, means very there is a relationship but negative. When negative means as the x increasing, the y is decreasing. And if you see minus 0.9, it is means high negative correlation, means there is a relationship, very strong relationship but negative. Perfect negative correlation, -1. Okay, it will give you the values like this. You will get to know the relationship, like whether it is positive, negative, or high, low. Okay, perfect, high, and all this. But if it is high, then how much high it is? We'll not get that idea. We'll get to know that yes, there is some relation. We'll get to know that, but how much correlated they are, we will not get that. Okay, so to do that, we have to try different formula. Does anybody know what is the formula for that? Like to know the actual intensity of the correlation. This will tell you just a measure. Okay, let me ask you very simple questions. Very simple question. Suppose there is a two column in the data. Okay. Oops. Yes, two column in the data, and it is showing covariance something. Wow, like amazing scatter plot. Yeah, what do you will say? What is this? Correlation or no correlation? Positive or negative? Tell me. Positive correlation. Perfect or high? Yeah, that is positive, fine. But perfect or high? Hmm, correct, high. High, positive, covariance. Okay, what if you will see something like this? Then what you will say? People are saying negative, high negative. High negative. I think this is no, yeah, low. I think low negative. Negative is fine. I think it's very low because there is not much proper pattern. Low negative coverage. Fine. चलो थोड़ा प्रैक्टिकल भी कर लेते हैं. ओके. तो फॉर एग्जांपल लेट मी ओपन दी collab. You people also open your Google Colab. We will be writing one code here. आई विल मेक अ डमी डेटा, ठीक है। हाँ, विल राइट हियर। तो ठीक है, तो व्हाट आई विल डू कि यहाँ पे डमी डेटा से मैं सिंपल तरीके से दिखाता हूँ कि कोडिंग के हेल्प से हम लोग कैसे कर सकते हैं। तो पैंडा को पहले इंपोर्ट किया और मैंने डमी डेटा बनाया है यहाँ पे, ठीक है। पहले आपको इजी तरीके से समझ लो, फिर मैं रियल डेटा पे भी इस्तेमाल करके दिखा दूंगा। एक्स और वाई हमने बना लिया, 1 2 3 4 5 6, जैसे आपको दिख रहा है कि ये को रिलेटेड है थोड़ा बहुत, ठीक है। अपने पांडास की डेटा फ्रेम बनाई, इसकी डेटा फ्रेम बन जाएगी आपकी। तो मैं पहले इतना करके ये प्रिंट करके दिखाता हूँ आपको। ये नेक्स्ट कोड पे लेता हूँ। यहाँ पे डेटा प्रिंट करके देखते हैं। देखो, आपको एक डेटा फ्रेम दिखेगी और 2 कॉलम दिखेंगे उसमें। दिखे? ठीक है, ये दो दो कॉलम है, एक्स और वाई। आप डेटा बढ़ा भी सकते हो वैसे। तो df.cov ये फंक्शन का यूज कर सकते हैं। तो यहाँ पे मैट्रिक्स के हेल्प से भी दिख जाएगी और नॉर्मल वैल्यू भी आपको दिखेगी, ठीक है। 1 दिख रहा है, राइट, यहाँ पे। तो कोवेरियंस आप देख सकते हो। वन वन का मतलब क्या होता है, चैट में आप लिखो। 1 का मतलब क्या होता है, इसमें 1 आया है। अगर इसमें आप डेटा बढ़ा दोगे थोड़े बहुत। 1 2 3 4 5 6 7 8 9 10 11। 3 6, 9, 10, 11, 3 एक्स्ट्रा हो गया, 3 यहाँ बढ़ा दो। आपको इस डेटा पे देखते हैं। किसी ने लिखा नहीं, कोवेरियंस 1 का मतलब क्या होता है? एग्जैक्ट पॉजिटिव, एग्जैक्ट पॉजिटिव और परफेक्ट। परफेक्ट परफेक्ट। अब देखो यहाँ पे क्या है ना, यहाँ पे हो गया है, मैंने रैंडम डेटा यहाँ डाल दिया बहुत ज्यादा। ठीक है, अभी देखो कोरिलेशन कैसे हो रही है। 6 बढ़ रहा है पर आपके दूसरे कॉलम का ज्यादा ही डेटा बढ़ गया। और जब ये एक्स बढ़ा था तो ये नहीं बढ़ा, तो कोरिलेशन बैठ नहीं रही इन दोनों में। ठीक है, कोवेरियंस का जो नंबर है इसलिए आपको बहुत ज्यादा नेगेटिव आ रहा है, नेगेटिव और वेरी हाई नेगेटिव। ये देखो, नेगेटिव और बहुत बड़ी वैल्यू नेगेटिव। लगभग वो इस कैटेगरी में चला गया, राइट। पॉइंट्स में रहा नहीं अब, बहुत बड़ी वैल्यू आ रही है इसमें। तो आप क्या बोलोगे इसको? क्या बोलना चाहोगे? परफेक्ट? प्लीज एक्सप्लेन इन इंग्लिश। या सो व्हाट डू यू वांट टू से दिस वन इज परफेक्ट नेगेटिव कोरिलेशन। हाँ, राइट, करेक्ट। Okay, so you also like add a random data and you can also see this. So people, please take the screenshot of this because time is almost up. We will be ending the session soon in 1 minute. Naman Singh, welcome. You looking happy. Okay, so you all of you can copy this code, fine, and please try covariance by yourself. In the next session, what we will do, we'll do the next topic like Pearson correlation, Spearman, and yes, all that. See this, see this. All right, have a good day. So I will be stopping the session now. Okay, have a good day.